Welcome. Today we will explore how electricity creates magnetism. When an electric current flows through a conductor, it generates an invisible magnetic field around it, a fundamental principle of electromagnetism. For a straight conductor, the magnetic field lines form perfect concentric circles centered on the wire. These lines are perpendicular to the direction of the current flow. To determine the direction of this field, use the right-hand thumb rule. Point your thumb in the direction of the current, your curling fingers show the direction the magnetic field lines circulate. The strength of the magnetic field, denoted as B, is inversely proportional to the distance from the wire. As you move further away, the field lines become more spread out and the magnetic force weakens. Field strength also depends on the amount of current. By increasing the current flowing through the conductor, we directly increase the density and strength of the resulting magnetic field. Now, let's see what happens when we bend that straight wire into a circular loop. This change in geometry significantly alters the shape and concentration of the magnetic field. Near the wire of the loop, the field lines are still circular. However, as we move toward the center of the loop, the magnetic field lines from all sides of the wire add together, becoming straight and parallel. A circular loop acts like a thin disk magnet. One face of the loop acts as a north pole and the other as a south pole, depending on the direction of the current flow observed from that face. To increase the magnetic field strength of a loop, we can increase the number of turns. The total field is the sum of the fields produced by each individual turn of the wire. In summary, a straight conductor creates a distributed circular field, while a circular loop concentrates the field at its center, creating a distinct magnetic dipole similar to a bar magnet. These principles are the foundation for modern technology. From the motors that drive our appliances to the speakers that play music, we rely on the magnetic fields produced by conductors and loops. We have covered the fundamentals of electromagnetism in wires and loops. Understanding these patterns allows us to harness the power of electricity to create motion and sound. Generated by Vision Solve AI.